All right, everybody, hello and welcome back. Today what we're going to do is we're going to talk about what we call a recursive formula. So to start here, it says list the first 5 terms in the sequence, and it provides us with an explicit formula. So you might notice that because we are multiplying on the inside, this is a geometric sequence. So if I want to find my first term, what I have to do is then plug in 1. So I have 2 times 3 to the 1 minus 1 power, which will simplify to just 2. If I want to find my second term, I do the exact same thing, except instead I'm going to plug in 2, and when I simplify, I get 6. If I want to find the third term, I do the same thing, and again, I plug in 3, which is going to give me 18. The fourth term is going to be 2 times 3 to the 4 minus 1, which is 18 times 3. Well, 18 times 2 is 36, 54, and that means that the fifth term is going to be 2 times 3 to the 5 minus 1, and that's going to simplify to 162. So it wasn't very efficient here. I had to do a lot of work. I took my equation each time to find the term I wanted. I would plug in that number to my equation and then simplify. That's how I got these values here. Now, if I asked you to list the terms, many of you would probably just tell me, okay, the first term is 2. The pattern is times 3. So 2 times 3 is 6. 6 times 3 is 18. 18 times 3 is 54. 54 times 3 is 162. What that tells us is our explicit formula is good for finding any term. It's not necessarily good for listing out terms. So for that, we have our recursive value, and the recursive value always is good for listing. Now, to do that, what I need is I need to know my first term, and I need to know the pattern. So my arithmetic recursive formula is going to be different than my geometric. What I'm going to have to do for arithmetic is I list my first term, and then I will list my pattern. Now the pattern is to find a term, you take the term that would come right before it, and we are going to add whatever the difference is. Similarly, geometric is going to be, we list our first term, and then I list the pattern, which is the term right before it, times the ratio. So this looks really strange, and a lot of students typically struggle with what a sub n and a sub n minus 1 really mean. So I'll show us an example here. I've got 2, 7, 13, 18. As we can see, I made this up, so these actually aren't the right numbers. This would give us 12 and 17. So the pattern here that I am going to be doing is I'm going to be adding 5 every time. So if I want my recursive formula, I list my first term, which is 2. And then the pattern is, to find any term, I take the term right before it, and I'm going to add 5. Now, just to make sense of it a little bit, if I wanted to find a sub 2, I would take a sub 2 minus 1 and add 5. Well, a sub 2 minus 1 is really just a sub 1, right? 2 minus 1 is 1. That means I would take a sub 1 and add 5, and we know what a sub 1 is. It is 2. So that means the second term is 2 plus 5, or 7. If I wanted to find a sub 3, I would take a sub 3 minus 1 and add 5. What that means is I would take a sub 2 and add 5, and a sub 2 is 7. 7 plus 5 is going to be 12. So this is how our recursive formula works. I need to describe the pattern here, but in order to get the right sequence, I need to let us know where the sequence is going to start. All right, and so all this work isn't always necessary. In order to list out the terms, really we just need to apply the pattern. So that means to find a sub 5, I would take a sub 4, which is 17, and add 5, which tells me it is 22. That was much more simple than having to write my explicit formula as we did above, and then plugging in. So that's the benefit of recursive formulas. Now we've got a little bit of a different situation here. We have a sub 1 equals -4, and then a sub n equals a sub n minus 1 times 2. What this tells us is we are multiplying by 2, that is a pattern, so it's geometric, and my first term is -4. So that means to find my second term, I take the term right before it, which is my first term, and I multiply by 2. My second term is -8. To find my third term, I take the term right before it, which is -8, and multiply by 2, which is -16. The more we practice, the better we'll get, and eventually I can simplify some of the work. I would take -16, that's a term right before it, and multiply by 2, that is -32. Again, this is the benefit of the recursive formula. If I asked you to list the terms, you would be applying this pattern in your head as is, as opposed to using our explicit formula and having to plug in every time to find the third and the fourth and the fifth and the sixth and the seventh and whatever it is. We have to do a lot more simplifying, when instead we can just apply the pattern to go from one term to the next. So we like the recursive formula, and it comes with two parts. There's a first term, and then there is the pattern, which is the second equation that is always listed in each of these. So technically, both parts of these make up our recursive formula. Now, we can also switch forms. We can switch from the recursive formula to the explicit, and it works pretty simply, pretty straightforward. As we can see here, the pattern is we are adding 3, so it is arithmetic. A sub n equals, well, arithmetic explicit formula starts with the first term, adds the difference, times n minus 1. We have all of the information available to us. We just need to put it into the right place in order to use the explicit formula. Now, this might be helpful because what if they gave me the recursive formula and they said find the 10th term? Well, I don't want to have to list out the second, the third, the fourth, the fifth, the sixth, the seventh, the eighth, the ninth, and then the 10th. Instead, I can switch from recursive to explicit, and then I can simply plug in 10. So it is easier in that sense if we switch forms. We have the same idea here. I have my explicit formula. As we can see, we are multiplying by a ratio, so it is geometric. So if I want to list out the terms, for example, instead of just plugging in 1, 2, 3, 4, 5, and however many and simplifying, I can just list the first term, which we are given, and then I will label the pattern, which means to find any term, I take the term that would come right before it, and I multiply by 1/2. So if I wanted to list, my second term is my first term times 1/2, which is 3/2. If I wanted to find the third term, I would take 3/2 and multiply by 1/2, and I can just kind of continue that pattern. So each equation is good for different things. Recursive is good for listing, and explicit formula is good for plugging in and finding any term that we want. Okay, as always, thank you for listening. If you have any questions or concerns, please feel free to ask. Thanks.